Assalamualaikum warahmatullahi wabarakatuh. My name is Lutfi from Ramen class. Here I will present my assignment. The title is Scheduled Soil Measurement Equipment. Table of content. First, introduction. A brief introduction about the report. 2. Literature review and research method. Theoretical review and how the data being analyzed. 3. Discussion. Explanation discussion about the scheduled tool. 4. Conclusion. First is introduction. Background. Theodolite is a precision optical instrument for measuring angles between designated visible points in the horizontal and vertical planes. The traditional use has been for land surveying, but they are also used extensively for building and infrastructure construction, and some specialized applications such as meteorology and rocket launching. It consists of a movable telescope mounted so it can rotate around horizontal and vertical axes and provide angular readouts. This indicated the orientation of the telescope and are used to relate the first point sighted through the telescope to subsequent sighting of other points from the same theodolite position. This angle can be measured with accuracy down to microradians or second of arc. From these readings, a plan can be drawn or object can be positioned in accordance with an exciting plan. The modern theodolite has evolved into what is known as a total section, where angles and distances are measured electronically and are read directly through computer memory. Author choose this topic is because author majoring in mapping, and this title is one of the mapping measurements tool. In a transit theodolite, the telescope is short enough to rotate about the Turnian axis, turning the telescope through the vertical plane through the zenith from non-transit instrument. Vertical rotation is restricted to a limited arc. The optical level is sometimes mistaken for a theodolite, but it does not measure vertical angles and is used only for leveling and horizontal plane. Stroke often combined with medium accuracy, horizontal range, and direction measurements. Research question 1. What is theodolite? 2. What are the parts of theodolite? 3. How to use theodolite? And 4. What are the advantages and disadvantages of using theodolite? Chapter 2. Research methods. An important part of research activities is the way in which used by researchers or research methods. In the research method required an approach that will be used as a foothold in the series research implementation. Choosing a particular approach in research must realize that it has its own consequences as a process that must be followed consist consistently from start to finish in order to get the best result, maximum and scientific value in accordance with the capacity, reach and purpose of that approach. Research method. Type of research. The type of research used in this research is research quantitative. Quantitative research method is one type of research whose specifications are systematic, well-planned, and clearly structured from inception to the design of the research. Research method quantitative. Location. This research was concu- conducted in Summerfield, Tampan District, Pekanbaru Regency. The research was conducted conducted in school in order to make it easier to observe and obtain accurate data about how the online learning process works. Uh, Data gathering method. First is observation, second is interview, and the third is documentation. Data processing method. The first is editing, second classifying, third verifying, and last is concluding. Sorry. Chapter 3, discussion. What is theodolite? Theodolite is one of the soil measurement instruments in geodesy which is used to determine the height of the soil with either horizontal or vertical angles and optical distance, unlike the water pass, which is both a measuring tool for measuring plane elevation. The theodolite is widely chosen by field surveyors because of its ability to read elevation level and determine the coordinates of a point. The angle that can be read in the theodolite is up to the unit of seconds. Basically, the working principle of this theodolite is similar to that of a telescope. That is a telescope that is placed on a spherical disc so that the surveyor can rotate it around a vertical axis. The use of this tool makes it easier for users to able to read horizontal angles. Theodolite is most advanced tool among the equipment used in surveying. Basically, this tool is a telescope that is placed on a rounded base or disc that can be rotated around a vertical axis. This following horizontal angles to be read. The telescope is also mounted on a second disc and can be rotated around the horizontal axis, allowing vertical angle to be read. Both angles can be read with a very high level of accuracy. Farrington, 1997. A survey using theodolite is carried out when the site to be mapped extensively and or quite difficult to measure, and especially when the site have a large relief or difference in height. By using tools in this way, the overall appearance or symptom will be mapped quickly and easily if efficient. Harrington, 1997. The first instruments, more like a true theodolite surface tool, was probably the one built by Joshua Habermas, uh, Erasmus Habermas in Germany in 1576, complete with compass and tripod. There is also a second disc on which the telescope is also mounted. The telescope installation of the theodolite also the instrument to be rotated around the horizontal axis, so that the theodolite is able to read vertical angle. It takes high accuracy to read the cats from this tool. It is recommended that this tool be used for only large sites or sites quite difficult to measure and sites with large relief or elevation difference. 2. What are the parts of theodolite? The first is the upper part consists of binoculars or telescope, nipple tube, ocular and objective screw, vertical motion screw, horizontal motion screw, binoculars for reading vertical and horizontal angles, LIFO box, binocular lock screw, vertical angle locking screw, minute and second adjusting screw, horizontal and vertical angle adjustment screw. The lower part consists of static or tripod, tribog NIFO adjustment screw, hunting, repetition screw, aircraft locking screw with stative, and theodolite components. The important part of the theory tool: binoculars equipped with sight, uh, vertical scale circle, horizontal axis, vertical scale circle reader index, horizontal axis support, horizontal scale circle reader index, vertical axis, horizontal scale circle, Nivo box, Nivo tube, T-brakes leg couples. Third, how to use Tedolite. First is Tedolite setting. Find a level plot of land with a good view between the land to be measured. 2. Extend the legs of the tripod so the Tedolite will be at a level that comfortable for you to use. As far as possible, most Tedolite tripod will have a mechanism that will lock them in when they reach maximum separation and extension, and anchor the ends of the legs to the ground. Adjust the three adjusting screws on the theodolite base so they are level. The screw level mounted on the theodolite will give you a picture of the parallel plane. Align the long level with two of the three screws and range ranks with the two screws to achieve a more accurate level on the axis. Then rotate the theodolite 90 degrees on the base and adjust it again using the third screw. Remove the two horizontal adjusting clamps, usually large knob and on either side of the theodolite slightly offset vertically. Align the top of the theodolite with the mark of the ring between the two sides connected to the horizontal clamp. Then lock the top clamp. Open the lens cover on the side of the theodolite and look through the small eyepiece. You'll see there three scales: horizontal, vertical, and fine adjustment. Use the adjustment knob on the top of the turtle to adjust the mark to 0 minute and 0 second from arc. Use the top horizontal adjustment knob to align the single line you see in the scope at the bottom of the horizontal scale right between the double lines that sit below the number 0. Create a reference line by stacking theodolites horizontally with height landmarks in an easy view. Unlock the bottom clamp to make this rotation. Align the view with the landmark and lock the bottom clamp again. The horizontal measurement will remain 0 from now only. uh, Knob clamp to make horizontally adjustment. Measuring using theodolite. First is unlock the top horizontal clamp and rotate the theodolite until the arrow in a rough spot lines up with the point you want to measure. Then lock the clamp. Use the top horizontal adjuster, not clamps. Align the object between the two vertical lines inside. Look through the small eyepiece and use the fine adjustment knob to get a horizontal line just right with your object. Degrees from your reference are measured on a horizontal degree scale, minutes and seconds on a fine adjust scale, 30 degrees, 10 minutes, and 30 seconds. Unlock the vertical clamp and look through the sight while moving the theodolite up and down to find the exact point vertically on your object that you want to measure. Lock the clamp and use the fine vertical adjustment knob to get the fix exactly at the point you select. Then lock through the small eyepiece and read the degrees, minutes and seconds of the vertical scale and fine-tune the scale as you walk for the horizontal scale. If your object is tall, you'll need to make a rough horizontal adjustment first. Then take a vertical measurement, then adjust for the final horizontal measurement. These two coordinates provide the exact angle between your reference and your point of interest. But you can also measure the angle between 2 points by comparing their two measurements or by setting the first point as a reference. The last question: what are the advantages and disadvantages of using to-do-lists? Advantage: 1. The operation is performed digitally on a computer basis. Because it is based on a computer, the to-do list is very consistent. If you want to process data, you don't need to re record it. Only by transferring data to the device, there are direct measurement results. 2. The angle reading is displayed on the screen of display. After aiming at the measure point, the angle we get is immediately displayed on the to-do screens. So there is no need to search manually anymore. 3. Able to measure horizontal and vertical angles simultaneously. With just one measurement, the to-do can get vertical and horizontal angles at once. Disadvantage: first, relatively more expensive. The price is around $3,500 and in rupiah it is around 50.841 Indonesian rupiah. Not anymore can have such an expensive tool. 2. Measurement results are affected by light. To use the to-do cannot be at night because it requires light in order to see the angel to be observed using a telescope. Dependence on resource: because these tools still use batteries, so to take measurement you must be prepared with a spare battery so that there is no error that the tool turns off due to running out of resource. Chapter 4: Conclusion. Based on the discussion, we can see that the Tedolet is a modern tool which is one of the soil measuring instrument in geology, which is used to determine the height of the soil with either horizontal or vertical angles. And optical distance: with the Tedolet, land measurement becomes easier and more accurate because the Tedolet is already carried on digitally based on computer and higher accuracy rate than geological compass. Clearing the part of the together from upper parts, lower parts, important parts that in the tool it turned out to have very many parts. That's why the tail is very concise and accurate in measurement. The author also provides steps for using the theodolite, starting from setting up the tool to taking measurement. There are something that maybe not everyone can have this theodolite tool, namely because the price is very expensive. The price is around $3,500 and in rupiah it is around 50.841 rupiah. Not everyone can have such an expensive tool. At night, this theodolite tool also cannot operate because this tool is influenced by light. Thank you for listening to me. Assalamualaikum warahmatullahi wabarakatuh.